So hello everyone. Today's topic is robot collision. So let's read the question. There are n one-indexed robots, each having a position on a line, health and movement direction. So like we have given a one-indexed array, and each has the position, its health and direction. Okay. So either left or right, all integers in positions are unique. All robots start moving on the line simultaneously at the same speed in the given direction. If two robots ever share the same position while moving, they will collide. Okay, so like two objects are on the same position, it will collide. If two robots collide, the lower health will be removed and health of the robot is decreased by 1. The surviving robot continues in the same direction it was going. If both robots have the same health, they are both removed from the line. If both are same, then both will be removed. Does determine the health of the robots that survive the collision in the same order that the robots were given. Okay. Okay. So here's the example. The position given are 5, 4, 3, 2, 1. Health is 2, 17, 10, and direction is RRR. So like as you can see here, let me change the color. Like everything is in right direction. Okay, this is on right, this is in right, this is in right, this is going right, this is going right. So like all have the equal speed, so no one will collide. So we will just return the array 10, 15, 9, 17, 2. Okay, because it will not, never collide with anyone. Okay, and if we take this example, we have one robot 1 at 3, 2 at 5, 3 at 2, 4 at 6. Okay, so like first this and this will collide, and because both are 10, 10, so this will and both will be removed from the match. Then 3 and 4 will collide with each other because it's left and this is right and this is left. So both will collide and 15 is greater. So like we will remove this and decrease its length by -1. So yes, we will return 14 as a health. Okay, suppose let's take an example. Suppose we are given a robot at 1, at 4, at 7, and at 8, and its health is like suppose we have four robots here. Okay, so four robots where health suppose 10, 5. We will take arbiter numbers 6 and 11, and this is moving this way, this is moving this way, this is moving this way, and like this is going to the left. Okay, so let's see, 10, 5, and 6 will never collide with each other because both are moving at equal speed. So here 11 will only collide. Okay, so first 11 will collide with 6, 6 will be removed, and it will be -1. So it will be 10 now. So now it will be 10. Then this will collide with this. So it's 5, it will be removed, and again -1. Then it will be 9. Now this object is less than, now this will collide with 10. And 10 has more health than this because this is 9 and this is 10. So this will be removed, and the answer will be 10. Simple. This is the hard question, and like the approach we can use, like we will just stop this direction and we will just iterate through this. Like I mean to say that we will we will just we will just make it speed 0, this speed 0 and this speed 0, and only the left part will move because it will help us to simulate the design. Okay, so what we can do is like we can use a stack structure here because we will first, because stack is d4, last in first out. Okay, so 10 will be added first, 5 will added first, 6 will added first. So 6 will first collide with this object. Okay, so we can use stack here, and we are making it 0. The speed of this right is 0, as it will make it easy to stimulate the design. Okay, so let's see the code. So as you can see here, let's do the code first. Let's do the code. Okay. Okay. First, we will create a stack, empty stack, and one result array, which will give us the answer. Okay. Then we will just do the indices because we have to first sort it. Because without sorting it, we cannot do anything. So we will first sort it. For sorting, like we are using indices for sorting it, like from 0 to 4, which will help us to sort the positions as per the positions of the robots. Okay. So indices is equal to like the list of range of, because we have to do it for positions, the length of positions. Okay. Positions. Okay. So like now we will just add, suppose we will make an array which will store everything like the position of the robot, health of the robot, direction of the robot, and the indices which will be using in future for sorting it. Without indices, it will just return the the robot in sorted way. So and it is not correct. And as it's mentioned here, return the array in the order they were given in the input. So we are use that. Okay. So we will use sorted zip to combine all the things. We'll make a tuple of it, which will add positions, then health, directions, and indices. Okay. Uh-huh. So now we will iterate through every robot and just determine it will be added in the stack, it's right or left, everything. Okay. So position, health, and direction, and index in the our robot structure, which have everything in it, which will save the all the items, like all the information of the robots. Okay. So suppose now if the robot is in the right, so we just have to add it because we are making it 0. So if direction is equal to like the right direction, then we will just append it into the stack. Stack dot append. We'll just append our POS, health, then direction, and index. You will say afterwards like what is the use of index, actual use of the index. Okay, you can just visualize it at that time. Else, if it's not right, if it's L, then we will just like iterate through the stack and remove everything. Okay, so while stack is not empty and health is greater than 0, as if it's 0, we just break it. Just it's a breaking condition. And then we will just remove everything, so it will get new position, like because we have to compare the top element, the rightmost element, which the element which is moving to the right, and it's at the like rightmost element, we have to select that. Okay. So health, nh, we'll just take, let's say nh, nd, n a, and idx. It will help us to reduce our time, right? And we'll just remove the top element. Okay. Then we will like now we will just see if like the rightmost element has the greater than the actual health, then we will just like do uh, health is equal to 0, and we will just reduce its the health of the rightmost element. Okay. Stack dot append P, npos nh minus 1, because it's given to reduce it by minus 1. Then direction, because it will not change, it will never change, indeed. And nidx, it's the index. Okay. Then elif, if as nh is less than health, then we will just pop it. So health minus equal to 1, we will just reduce it by 1. Okay. Else if it's both are same health, then we will just do health, health is equal to 0. Okay. And now like if the we are coming out of the loop after removing, after with the collision of all the elements, So we will just take like if health is greater than 0, then like we will just push it into the stack. Okay. So like result dot append pos health direction and idx index. Okay. And now like we will just come out of the loop. Yeah, we have to just use it here, not here, because it will take in the rest. Okay, my bad. Okay, so now we are just coming out of the loop, and we will just add everything from the stack to into the result array. Okay, and then we just sort the result array. Sort key is equal to lambda uh, lambda x x of 3. We are taking x of 3 because we have to sort it as per the index which we have saved before. And then we will just return result. We will just return, sorry, my bad. We are just health now. So we will just return the health we will just iterate. Position we will iterate. Health, we have to we'll iterate this in result. Okay, so let's check. Let's check. Array. Positions is not defined. Oh shit. What can I do? Errors. Yeah. Sorry guys, we are getting a lot of error. And what's the error? Huh? Wait. Stop. Yes guys, I have resolved the error. Yeah, so it was an error in the stack program. It's adding double times, 2 times. So yeah, sorry for the trouble. Yeah, I got it right. Yeah, done it. As you can see, 66%, 917 millisecond, and it is almost n square and log n. Okay, almost optimized. Yeah, please comment down if you have any better approach than this. Thank you.